Hello everyone. So today we will be starting with the data link layer, which is the layer 2 of the OSI model. So this is the OSI model we'll be referring to, and we'll be covering these topics, which is MAC, LLC, serial versus multi, and transmission types. So before we start, there are going to be a few protocols we'll be going through. So the first one is a very commonly known one, and it is called Ethernet. So everybody knows what Ethernet is, or at least has some basic idea. If not, we'll quickly go through what it exactly is. So it is a widely used protocol for a wired LANs. So LAN is a type of network, which means local area network. So for example, if I were to draw, there are two computers, right? Two or more than two computers. So Ethernet, what it essentially does is that it provides a sort of technology which is able to send data across these two computers without any other outsourcing or without any other um, source. So no ISP or anything. It just sends data across each other. So this is what Ethernet is. So it defines framing, structure, addressing, access control methods for data transmission over physical media, right? So how does it do that? Well, just to inform you, it uses this thing which is called as MAC addressing. So each computer, each system, be it a device like your mobile phone, your computer, printer, etc., so it contains something which is known as a MAC address. So this MAC address is inbuilt into the computer, and it uses this MAC address to communicate. So computer A here would have a specific MAC address, and computer B would have a specific MAC address. And while transmitting this data, computer A will use this MAC address, like the address of your house. It's very specific. So to send something to your house, they would have to use your address. Similarly, it will use this address, and that is how data is transmitted in Ethernet, right? So the next protocol we'll be seeing, it's called point to point, or PPP. So this protocol is used for direct connection between two nodes. So it is not widely used now. It's all because obviously it's only between two nodes. So if there is, say, a computer and an ISP modem. So these are two nodes, and here we'll see PPP happening, which is point to point. And obviously, this is not feasible as today, right now. This is a kind of an old technology, because today we need more than two. We need to connect so many others, so many connections needed, right? So this is not possible because we need so many connections, and it is not feasible anymore. So this technology is very rare to see. A difference from Ethernet would be that this does not use any MAC. So there is no MAC addressing involved here. There is no MAC addresses. You don't use it here. Also, it is less common, and it only involves two devices, right? So this is a PPP. This is a type of technology or a protocol in the data link layer. Another one is called frame relay. So frame relay, it is not in LAN. It is basically a WAN technology. So WAN is a wide area network. This is covered in the basics of networking: WAN, LAN, CAN, SOHO, all of that. So WAN is a wide area network. So what it does is that it connects geographically separated LANs. So for example, if there is a building which has LAN technology inside it, in the sense there are labs and they're all connected with Ethernet, and there is another building a bit far apart, the roads and trees everywhere, and this also has LAN. So this whole connection is happening over WAN, right? They're connected to each other. It's like a big it's a big interface. So my point is that there is what frame relay essentially does is that it sends data packets over virtual paths over long distances. It sends data over long distances using virtual paths and over shared WAN. Okay, and it's like a packet switching technology used for connecting LANs and WANs, and it provides a simple way to transmit data frames over a shared network. So this is what frame relay is, but it is being highly replaced again. This technology is outdated, and it is being replaced by something which is called VPN. and which is more commonly people use this a lot. So this technology, this protocol is also not in use in the data link layer. Finally, we'll be coming to something which is extremely important and which I mentioned before, and it is called MAC. Right. So this is basically the foundation of the whole data link layer, Ethernet, LAN technology. Everything resides on this. So what is it? What do you mean by this address? Like what? How does it? What is it constituted of? So what it is its full form. First of all, let us start with that. So what it means is it is called as its full form is media access control. Pretty basic, right? So it also is basic. So what it is that it provides physical addressing. So IP, all of that, everybody knows what an IP address is because it's a common term now. MAC address, not people don't know it much. So IP is like in the network region, all of that. But MAC, what it is literally inside your computer. This is the address, this is your whole system, and it is literally inside the computer. It is essentially a 48-bit address. And how is it expressed? It's a 48-bit address, and it is expressed in 12 hexadecimal digits. So there are two parts to this. So this whole thing is the MAC address, okay? And there are two parts of it. One is called OUI and the other is called NIC or NIC. What this OUI is, it is predefined by the IEEE first of all, and this is distributed directly by the vendor. So if I buy, say, an HP laptop, so the HP vendor, HP will be providing me this NIC card, while IEEE will give this OUI card. Okay, or these bits. So this comprises of 24 bits. This is also 24 bits, out of which there are 6 hexadecimal digits and 6 hexadecimal digits. So it's in a total, it's a 48-bit address with which has 12 hexadecimal digits. Right? This is what it is. You know what exactly a MAC address comprises of. So this is the whole address. Okay, and the most important part is like I mentioned before, all of these MAC addresses are totally unique. They are unique to each device. No two devices have the same MAC address. There are so many possible combinations. This is given by the vendor. This is given by IEEE. So they're completely unique, and that is how they communicate. Because which in Ethernet they're communicated by Ethernet frames. So these Ethernet frames basically have they have something which is known as a source MAC address and destination MAC address. So this is what an Ethernet frame basically constitutes of. So moving on, we'll be talking more about it when we discuss the data link layer functions. For now, I'll be talking about another concept which is called the LLC. Okay, this is stands for logical link layer. There's not much to it, but all I can tell you about this logical link control, my bad. This is called logical link control. So what I can tell you about this is that, for example, now this is my OSI model, right? So there is a layer which is called the network layer, and then this whole box I'm drawing is the data link layer. Okay, and the upper part consists of, this is like sub level, this is the LLC, and this is the MAC. That is what data link layer, this is a sub level. This stands on the upper and this stands on lower. And basically the job of this LLC is to bridge the network layer and the MAC layer, which are the most essential bits. We've not talked about network layer, and we will not do anything about it in this video at least. But MAC addressing, LLC is a sublayer of the data link layer, and it provides a way for the upper layers of the OSI, not just network but the other upper layers of the OSI to communicate with the data link layer, while also managing communication between devices on a LAN, right? So the MAC sublayer uses physical, this is all about physical addressing, while logical link control uses logical addressing. Okay, we'll be talking more about that later. So this is what you need to know. This is the basic ideal structure of the data link layer, where you have the upper layer as the logical layer and the lower layer as the physical layer, LLC and MAC respectively. Okay, so then after that we have the data link layer functions, right? So these are important steps where you get to know what exactly data link layer does and how it works, especially in Ethernet. Okay, so the first most important step is framing, because you need to frame, how you're sending the data, everything. And this job is done by MAC, because you need addresses. Like for example, if I'm framing, I have to send a message, so I will need to, if I'm sending a message, this is my message. Okay, I first will need to draft it, so I need to frame it according with the structure and everything. So all of that is done physically, which is done by the MAC. So it encapsulates the network layer packets into frames. So what does this frame do? What does this frame include? So it not only includes the actual data, so this is the actual data, but it also includes headers and trailers. So I'll be talking about that in some time. But this is what what framing is. The next part is uh, the next part is addressing. This is the second step in, the second function, I would say, and it is also done by MAC. Okay, so you're supposed to use physical addresses. I mentioned this before. It's physical addressing. You're talking about LAN, Ethernet, all of those concepts in the data link layer. So it uses physical addresses to identify device on the same local network. So it's all about physical addressing on the same local network. Okay, so the next one is also important. The next part is is done by LLC, which is called error detection. So this is the third function of the data link layer, which is done by LLC this time. So what it does is that it implements these mechanisms to detect and correct errors during which occur during these transmission techniques, and they include things such as checksums. So I mean, there are algorithms, mathematical algorithms which these checksums use, and they solve, they detect errors and they correct them. So there is something which is known as a cyclic redundancy check. Okay, and it's a mathematical algorithm which is used, frame check sequence. I mean, there is a lot, but we won't be diving into that as it is of lesser importance. But all you need to know is that there is a step called error detection, and it is done by LLC, which enforces these checksums to correct and detect errors which occur during data transmission. Okay, now we are going to talk about something really important, which is basically called the frame structure. How is the data actually sent here? Like, what you talked about structure, you talked about addressing, you talked about MAC being physical addressing and all that, but how are these Ethernet frames actually sent? So it's a big, it's a big thing. It's like, basically frames. I'm just going to draw them right now, and hopefully it'll be understandable. Okay, so these are frames, and inside these frames I will include other ones. So this is my MAC header. Okay, bear with me. And this is my payload. So what I keep saying payload, what is it? Payload actually means data, the actual data, the actual message you want to send. So you can't just send that, because you will need these headers and trailers. Who are you going to send this data to? It could get lost anywhere. So, and this is the CRC checksum. Okay, so what does this MAC header include? So this MAC header, it includes the destination MAC address. Okay, it includes the destination MAC address. Then it includes the source MAC address. I'll be talking about this as well. It includes the source MAC address, and it includes the ether type. So these are kind of words which you will be like, okay, I'm hearing this for the first time. And this includes the payload. So this includes the actual data, whatever you want to send, the data. And this one is basically a CRC checksum. So, error detection, correction, all of that. So, you include that in the last. So what is this exactly? Destination MAC address. Where do you want to send this data? Where are you going to send this? And from whom? This is you. So sorry, yeah, so your MAC address, the computer A is sending it to computer B. So computer A, and this is computer B, so where you're sending the data to. Ether type, so this is interesting. Ether type is basically a protocol identifier. So it sees which protocol is being used. So is it IPv4 you're using, is it IPv6? So it corresponds to whichever protocol is being carried in the data, which whatever it's being carried. For example, 0800, that is IPv4, right? So that will be mentioned here in the ether type, whatever this data is, whatever it's following, whichever value it corresponds to, that is the ether type. That's it. No fuss. And this is the CRC checksum. Like I said, it is based by LLC. It checks and it verifies with the all of the errors which occur during these transmissions, and it corrects it, verifies it, and that's all. That is all that it is. So this is a very basic frame structure of the Ethernet. This is an Ethernet frame, and this is how it is. Communication happens between wired LANs, right? So there's a destination MAC address, there's a source MAC address. Obviously, all MAC addresses are unique, so they'll have to, that is how they work. There's an ether type, then there is the actual payload, which is the data you're going to send, the message, and then there is CRC checksum. Okay. Now we're going to come to, I think, the third part of this, which is you will get to know more about Ethernet and PPP here. So it's called serial versus multi-access. So what is this? So serial. Okay, serial. So what does this? This is basically an example how PPP is structured, how it is layered. So here the data is transmitted one bit at a time. So these are basically the types, how you transmit data. Okay, it's basically what it is, how is it accessed, how is it transmitted. So PPP, data is transmitted one bit at a time over a single channel. Okay, over a single channel or a wire, and only one data line is used for transmission. So point to point, for example, I have a device. I will send it across the network, and I'll receive it. So this is basically an example of serial access, how you're accessing the data. There's only one. So as you can see, there is only this is the only one, channel, one wire goes across the internet, and it is transmitting only one bit at a time. So it's like a serial, it's in one line. So that is PPP. That is an example, how PPP is transmits data. Okay, another one, which is basically called multi-access, right? So multi-access, it might be clear now. Multi-access is basically multiple devices access the same communication medium simultaneously. So basically I'll have like multiple, if I am sitting in a computer lab or a library which has computers and laptops. So I am going to access one channel. So I'll have, these are my other computers, and you can see, so I am accessing this, I am accessing this, then this and this. So these are basically accessing multiple devices are accessing the same communication medium simultaneously, and this is essential in network environments where devices share the same bandwidth. So these are accessing the same communication medium. So this is one communication medium, but there are so many. There are like one, two, three, four, five. So five devices are accessing one communication medium simultaneously. So that is basically what multi-access is. This happens in Ethernet. So it could be your in your lab, like I said, home office, multiple devices attached to each other like this. And this is also an example of frame relay because it's a shared path, shared WAN path, where they have virtual paths, and it they send data over long distances using WAN technology. So these are multi-access. Ethernet is done accesses data during using multi-access, and so does frame relay. Okay, so now we're going to go to the last part of this whole data link layer, having concluding this brief overview. So I haven't gone much in depth, but it is enough to understand what data link layer essentially comprises of. And we're going to start with the last topic, which is called transmission types. Okay, so there are three transmission types. I'll be talking about them. So transmission types. First one, okay, simplex transmission. What is it? So data is transmitted only one direction. Receiver cannot send data back to the sender. Any famous example for this? I will tell you. TV. You watch TV, you get the information, but are you able to send anything back? No, you are not. So this is a type of simplex transmission. Only you are receiving data. You cannot send any data back. In a broader term, this is basically called broadcasting. This is what it is. This is simplex transmission. Receiver cannot send data back to the sender. Another one, which is called the second one, which is called half duplex transmission. What is this? Device can send and receive data, but it must switch between modes. So that basically, to elaborate, it basically means that while one is transmitting, okay, one is transmitting, the other must wait until the transmission is complete before it can respond. So I am from one device. Okay, so I am from one device A. If I am sending, B must hear, and when B is sending, A must hear. You can't talk simultaneously. You can't be in an active conversation with both of them are talking. So when one is talking, the other must hear, and when the other is talking, the one must hear. This is what it is. So another very famous example of this is basically walkie talkies. So when one is on the walkie talkie, when one line is occupied, the other one must hear. So I am talking from device A, my walkie talkie, and this is walkie talkie B. So I'll be saying something, the other person will have to hear, and until that the transmission happens, until the other person stops, and then you can tune in and you can talk to person A. So that is what half duplex means. That means when one is transmitting, the other must wait until the transmission is complete before it can respond. Okay, and the last one is called full duplex transmission. So data is transmitted in both directions simultaneously. Both devices can send and receive data at the same time. So it is basically both. You can both talk, you can both transmit data, you can both receive data, you can both respond data simultaneously, all at once. So obviously you can just say, when you're talking real time communication, when you're talking to each other, you can interrupt each other, you can respond, you can do whatever you want. It's real time communication. You can or it could be a video conference, where there is both parties can talk and listen, and they don't have to wait until the other person. Obviously that is more beneficial, but you still can talk and chat. So this is what full duplex transmission is, and with that we have completed a data link layer, of the OSI model. it's a brief overview, brief layout. We talked about transmission types, we talked about serial versus multi-access, we talked about the frame structure. We also talked about LLC, what is, the logical part, and then the physical part, which is the MAC addressing. All of this comprises, in the data link layer, Ethernet frames. We talked about all of those three protocols, which is basically Ethernet, PPP, and frame relay. And with that, we conclude this data link layer. There's obviously more to it, but we've just talked about the brief overview and given an idea.